Alright guys, so in this lecture we are going to focus on the acid-base properties of salts. Under the acid-base properties of salt, we are going to be identifying the types of salt. We are going to define and give examples of buffer, identify the types of buffer, calculate the pH of buffer, and then solve problems for buffer systems. Now generally, my dear student, you know that whenever acid and base react, what is it going to form? It usually forms salt and water, right? A combination of acid and base forms salt and water. Now, we have different types of solution. Let's take that down. We have different types of what? Solution. The first type of solution we are going to look at is the neutral solution. There we have the another type of solution which is called the acidic solution, and then we have another one which is called basic solution. So these are the three types of solution and the neutral solution. Now we can also call them salt, but we can call them salt solution because we know that when acid and base react, we are going to form salt and water. So a mixture of salt and water is called what? Salt solution, right? Now, depending on the nature of the acid and the base that react and the strength of the acid and the base that react, we can form different type of what? Salt solution, or different type of solution. And this type of solution is now where we have the neutral solution, the acidic solution, and then the basic solution. Do you understand the concept? So based on the strength of the acid and base that react, to give us this different type of solution, salt solution. Now, if you have a strong acid and a strong base, or you have acid and base in such a way that they neutralize each other completely, you are going to form a neutral solution. But if you have acid and base in such a way that the strength of the acid is greater than that of the base, you are going to have an acidic solution. In a situation where you have acid and base mixture reaction, when the strength of the base is higher or stronger than that of the acid, you are going to have a basic solution. Alright, now that you've understood this, let's now look at neutral solution in detail, and then look at everything that we need to look at for under neutral solution. Now, the neutral solution is formed when from a strong acid and a strong base when they are dissolved in water. So they say salt formed from a strong acid and a strong base is dissolved in water is forming what? A neutral solution. What I mean by that statement is, whenever you have a strong acid, example of strong acid is what? Sodium hydroxide plus, strong base, sodium hydroxide. Strong acid is HCl. Now this will give us what? Sodium chloride plus water, H2O. Now this sodium hydroxide is a base and a strong base at that. This is an acid and a strong acid at that. This is a salt solution. So this is the salt that is formed from the reaction of sodium hydroxide and HCl. The salt that is formed is this salt here. Do you understand? Now when you dissolve this salt in water, it's going to give us this neutral solution you have here. So neutral solution are formed when strong base and strong acid react in such a way that they form salt, and that salt is dissolved in water. Is that okay? Now, examples of those kinds of salt are salt containing an alkaline metal or alkaline earth metal, except beryllium. Those type of salt are salts containing, most salts containing alkaline metal, right? Containing alkaline metal. Alkaline metal are group 1 elements in the periodic table and group 2 elements in the periodic table are called alkaline earth metal, except beryllium. So beryllium do not form neutral salt. Is that okay? Beryllium is what group in the periodic table? Of course, is alkaline earth metal, is group 2. And the conjugate base of a strong acid. Are you getting it now? And the conjugate base of a strong acid. So whenever you have a group 1 metal and a group 2 metal bonding or joined together with the conjugate base of a strong acid, the conjugate base of strong acid are stuff like Cl minus, right? Br negative, and NO3 minus. What are the different acids that gives this conjugate base? Of course, you know Cl minus will come from what? HCl. Are you getting it? Then Br minus will also come from what? HBr. Then NO3 minus will come from what? HNO3 negative. HNO3. So these are the different acids, and then these are the conjugate base. Is that okay? So when you have a group 1 and group 2 metal, and the conjugate base of strong acid forming a salt, that salt is said to be a neutral salt. What do you mean by that statement? Let's take an example of such. We have, my dear student, you have sodium chloride. Now sodium is what? Group 1 metal. That is where this one comes into play. Chlorine is the conjugate base of a strong acid. So a combination of a group 1 metal and the conjugate base of a strong acid gives that kind of salt, which when dissolved in solution form this neutral solution. Is that okay? Now that is that. Now, why is it like that? Why do you think that these salts are neutral salts? Now listen. A salt is neutral when it is dissolved in water. It's not able to form either hydrogen ion or hydroxyl ion. That's when you say a salt is said to be neutral. Take that. A salt is said to be neutral in such a way that when you dissolve that salt inside water, it's not forming sodium ion or what? OH ion. It's said to be neutral. If it forms H plus ion, that salt is acidic. If it forms OH negative ion, that salt is what? Is basic. Now, if you take sodium chloride, for instance, and dissolve sodium chloride in water, so you are going to have sodium chloride dissolve in water. All right. Now, this is going to give us sodium ion. It's going to break to give us sodium ion and what? Chloride ion. Now, this sodium ion and chloride ion cannot be further hydrolyzed. When you say cannot be further hydrolyzed, it means it cannot be further broken down by water. So it's not going to form H plus ion or OH negative ion. These kinds of salts are said to be what? Neutral salts. Is that okay? So if you are asked to give what neutral salts are, you can say neutral salts are formed when there is equal strength, or when acids and base that reacted, they completely neutralize each other to form a salt, such a way that when that salt is dissolved in water, it's going to form a neutral solution. Do you get it? And then they are often salt containing group 1 and group 2 metals or elements, and the conjugate base of a strong acid like Cl negative, Br negative, NO negative. And the reason why it is like that is because when this salt dissolves in water, they form ions which cannot be further broken down by water to give either H plus ion or OH negative ion. So you say those kind of salt are neutral. Now, the next one is basic salt. Now, what are basic salt? What are the compositions of basic salt? Basic salt are formed from a strong base and a weak acid. So when you have a combination of a strong base plus a weak acid, what you form is a basic salt. Is that okay? You see that in this case the base is stronger, so it means the base will be much more visible, like its presence will be felt more. Is that okay? Those kind of salts are solutions are called basic solution. Of course, they are going to form the salt first in such a way that when that salt dissolves in water, the kind of solution is going to form will be basic salt solution. Exactly. Now let's take an example of that. You have sodium ethanoate. Sodium ethanoate is a strong base, which is CH3COONA, plus then let's say sodium ethanoate dissolves in water. Sodium ethanoate dissolves in water, or sodium ethanoate is not a base, it's a salt. Sorry. And you know where sodium ethanoate is formed from. Formed from the reaction between what? Ethanoic acid and, are you getting it? So ethanoic acid and sodium hydroxide. Believe so? Ethanoic acid and sodium hydroxide. Something like that. Now this is going to form the sodium ethanoate. Are you getting it? Now ethanoic acid is a weak acid. True or false? Plus sodium hydroxide is a strong base. So this is going to form sodium ethanoate plus water, H2O. These kinds of salt formed by these reactions are known as what? Basic salt. This is a weak acid. This is a strong base. It forms this salt, which when dissolved in water forms a basic solution. Alright, now this sodium ethanoate that is formed, I told you that one of the ways to know if a salt will be acidic or basic is the production of what? Either H plus ion or OH negative ion. Right? Now let us look at this sodium ethanoate. If you dissolve sodium ethanoate in water through hydrolysis, now this is going to break this compound down and it's going to form the ethanoate, and then you are going to form sodium ion, because this stuff is going to break this thing down. Are you getting it? This water is going to break this thing down into two different ions. That's why most times we don't state as plus water, but rather you say it is hydrolyzed with water. That means you pass it through water. Are you getting it now? So this, you call the process here hydrolysis. Hydrolysis. Is that okay? Good. Now that you've gotten this, the next case now is you take this ethanoate that is formed, are you getting the ion, ethanoic ion, and then you hydrolyze it with water again. Like I told you that it's the ability, you know, when we form this, the other case when we form sodium chloride, we now form sodium ion plus what? Cl negative ion for the first case. And I told you that this sodium ion and this Cl negative ion cannot be hydrolyzed to give us either H plus or OH negative. It cannot be hydrolyzed to give us H plus or what? OH negative. So we now have this ethanoate plus, if you hydrolyze this with water, H2O, now this is going to give us, in a backward reaction, are you getting it? Reverse reaction. Now of course water will be acting as an acid in this reaction, and if water is acting as an acid, it means it can donate a proton here. If water donates a proton here, what are we now left here with? OH negative, right? So this is going to give us CH3. Here will be what? COOH plus what? OH negative. This is ethanoic acid plus hydroxyl ion. This hydroxyl ion is what makes this compound to be a basic solution. Basic solutions. Why? Because at the end of the entire process, it forms the hydroxyl ion. Do you understand the concept? So in this case now, you see that when a strong base and a weak acid react, it forms a basic salt. That basic salt can be hydrolyzed with water to form what? OH negative, which makes it a basic solution. Are you getting it now? So that is that for that situation. Now let's look at the last one, acidic solution. So we say for basic solution, you have strong base plus weak acid. For acidic solution, you have weak base and strong acid. Weak base and strong acid. An example of such is ammonia is a weak base. It's not classified as one of those strong bases. Pure solution of ammonia plus example of strong acid is ACl. Aqueous. Now this is going to give us, when ammonia reacts with ACl, what are you expected to form? You are going to form ammonium chloride. Aqueous. In solution. Are you getting it now? You are going to form ammonium chloride. Now, if you put ammonium chloride in water, this ammonium chloride that is formed now, if you put it in water, it's going to dissociate. So we have, this is the salt formed. ammonium chloride, you pass it through water, it's going to dissociate to give us the ammonium ion plus chloride ion. It's going to dissociate to give us the ammonium ion plus chloride ion. Is that okay? Now, this ammonium ion can be hydrolyzed. It can be hydrolyzed. So if you take this ammonium ion now plus water, H2O, in this case, this ammonium ion here is an acid. Are you getting it? Is an acid. So this ammonium ion will act as an acid in the presence. No, we said water can act as an acid and also as a base. So this one here is the acid. Why in this case this one here is a base? And you know what an acid is, my dear student. What do you say acids are? Acids are proton donor. So this is going to donate a proton to this. Now when this donates a proton, you are going to form this compound. This is now going to give us NH4. Now this no longer be NH4 because it's donating H plus from here. It's going to donate a proton, H plus, to this one. So if you donate H, it means you are now left with what? NH3, right? Good. Then the positive sign is also out. So here will become NH3 plus. Now when that H adds to H2, it gives us H3O, of course, plus the positive charge, which is H3O plus. Now, my dear students, what is this? What is this? This is an acid. This hydrozonium ion, which is the positive ion that is formed by acid. So you are going to form acidic ions in solution. Hence, this kind of solutions are known as what? Acidic solutions. So that is the basic fact about acidic solution. Now, however, chloride ion, you see this case now, this chloride ion do not react with water to form OH negative, because sometimes now some person will not be like, why are we taking the positive sign? Why are we not taking this Cl negative? The chloride ion on itself do not react with water to give us, you know, if you want to react this thing now, you now say HCl plus OH negative. This reaction do not occur. Does not occur. All right, so that is that. Now that we've learned this, the next thing we are going to look at is solution in which both cations and anions are hydrolyzed. Now in this case, all what you have here is one of them is hydrolyzed. If you look at this case, the anion for basic salt is what is hydrolyzed to give us this. If you look at this case, what happened? The cation is what hydrolyzed to give us H3O plus. Why for neutral solution, none is what hydrolyzed. Neither sodium is hydrolyzed nor chlorine is what hydrolyzed. Now we have some solution where both cation and anions can be hydrolyzed. Solutions where both cations and anions can be hydrolyzed. Now in such a solution, how do you predict the acidity and the basicity? Now you use some certain key terms to predict them. Now if Kb, that is the base dissociation constant, is greater than Ka, right, for cation, the solution will be basic. Is that okay? So if Kb for anion is greater than Ka for cation, the solution will be what? Acidic. Now, however, if Kb for anion is less than Ka for cation, the solution will the solution will be basic, not acidic. Here the solution will be acidic. You can see Kb, that is the base dissociation constant. Now, what does Kb give? What information does Kb give to you? It means that the strength of the base is higher than the strength of the acid. I told you that when the strength of a base is higher than the strength of the acid, what are you expecting? A basic solution. Now how about if the strength of the base